Hello everyone, welcome back. In this video we are going to learn another important concept in Java multithreading, that is locks in Java. So we will see with some practical example and with clear explanations, okay? So subscribe to the channel to keep learning and growing your Java skills. Now let's get started. So we already learned how synchronized protects shared data from the race conditions, right? So we already have the concept of synchronized. So with the help of synchronized, we have seen it prevents multiple threads from entering critical section at the same time. So let's say we have some critical section. Inside we have some variable and multiple threads are trying to use it. But with the help of synchronization, we have resolved this issue. Okay. But why does Java also give us lock and reentrant lock features for resolving this concurrency? So a thread acquires a monitor lock, enters the critical section, and other threads using the same lock must wait. So if synchronized already gives us locking, why does Java provide an entirely separate lock API? So this is like different lock API. Why would we write lock and unlock manually when synchronized already manages locking automatically? Okay. So the answer is control. So the Java is giving control to us to lock or unlock manually with this kind of APIs. In synchronized, locking and unlocking were executing by Java automatically. So here we have a more control for locking and unlocking. We will see how it is. So explicit lock provide capabilities that synchronized does not provide us directly. Okay, such as attempting to acquire a lock without waiting forever, interruptible lock acquisition, configurable fairness with certain lock implementations. So these are the features of lock and reentrant lock. So in this video, we will understand the lock interface, reentrant lock, lock and unlock. And finally, we'll compare between the synchronized and the lock. So you know when each approach makes sense. Okay, which approach you should choose based on our requirement. And there is one dangerous mistake you can make with unlock that can leave other threads waiting indefinitely. Okay, so we will make sure you never make that mistake. Okay, so the synchronized keyword is simple and very useful. Okay, we enter a synchronized block here, synchronized block, and inside which we will be having one critical section. So Java acquires the appropriate intrinsic monitor. Okay, and this monitor is automatically released when execution exits this synchronized block. Okay, so for many synchronization problems, this is exactly when we need. But sometimes we need more control over how locks are acquired and managed. So when we need more control over locks, okay, so for example, what if we want to attempt to acquire a lock and do something else if it is unavailable? Let's say we are trying to acquire a lock. Let's say there is one critical section or synchronized code and one thread is currently acquiring it. And let's say we have another thread, it is trying to acquire but it is not able to acquire because another thread is already acquired this critical section. So in such cases, we want this thread to do something else. Okay. And what if we want lock acquisition to be interruptible? Or what if we want an optional fairness policy? So for this kind of requirement, Java provides explicit locking APIs in the java.util.concurrent package, concurrent.locks package. Here it is written. Okay. So within this package, it belongs lock. Okay. So we have for that lock interface. Okay. So lock is an interface in the java.util.concurrent.locks.lock. So this is lock interface belongs to this package. It defines explicit locking operations. Okay. Some important methods are lock, unlock, tryLock, lockInterruptibly, new conditions. Okay. So in this video, our main focus will be on lock and unlock, these two. But methods such as tryLock and lockInterruptibly help explain why the lock API exists. Okay. So the lock interface itself defines the contract. Okay. So to actually use it, we need an implementation. Contract means what? Because this is an interface, right? There will be only method declaration, but implementation will be provided somewhere else. Okay. So we need an implementation. So one of the most commonly used implementation of this lock interface is ReentrantLock. So this is like implementation class of this interface. Okay. So it will be like something like class ReentrantLock implements lock. Okay. So now we will see the ReentrantLock. So ReentrantLock is a concrete implementation of the lock interface. So we can create a lock reference and assign a new recurrent ReentrantLock. See here, we created a new lock and we can assign to a new ReentrantLock to it. So ReentrantLock provides mutual exclusion similar to synchronized. Okay, if one thread holds a lock, okay, one thread is holding a lock. Another thread that needs the same lock cannot enter, right? It cannot enter. Why? Because T1 is holding the lock. So it cannot enter the protected critical section until the lock becomes available. So once it becomes available, then only it will be having the rights to acquire the locks. Okay. But unlike synchronized, we explicitly control when we acquire and release the lock. We can control these things. That gives us more flexibility. Okay. But it also gives us more responsibility to manage lock and unlock. Okay. Now, you may be wondering why it is called ReentrantLock. What is the meaning of this ReentrantLock? So reentrant means that a thread that already owns the lock, okay, can acquire that same lock again. That's why the name is reentrant. Okay, so let's say there is one lock acquired by one thread. Okay, so a thread that already owns the lock. So this T1 is already owning this lock. So it can reacquire the same lock again. That is reentrant. So the lock keeps track of how many times the thread has acquired it. Okay, so lock method will keep a track how many times this thread has acquired this lock. Okay, and then the thread must also then release it the corresponding number of times. Okay, so if 2 number of times it is acquired, so 2 number of times it should release the lock also. Okay, so this behavior is also conceptually similar to Java's synchronized intrinsic lock, which are reentrant. So the name ReentrantLock makes this behavior explicit. So for most basic examples, we acquire it once and release it once. Okay. So let's see how. Okay. So the lock method acquires lock. So this will acquire the lock. If the lock is available, the current thread acquires it and continues. Okay. So suppose we have lock and some thread is trying to acquire the lock. If lock is available, the current thread will acquire this lock and will continue. And if another thread already owns this lock, the current thread will wait until this lock becomes available. So once the thread owns the lock, okay, once the thread owns the lock, it can safely enter the critical section protected by this lock. Okay, it can enter the critical section. But unlike synchronized, Java will not automatically call unlock. Okay, because in synchronization, this locking mechanism is intrinsically happening, means automatically happening. We are not controlling those things, lock and unlock. Java is doing in synchronized. But as part of ReentrantLock, we need to manage those things, locking and unlocking. Okay, so we leave an arbitrary code block. We are responsible for releasing the lock correctly. Okay, so since we are locking, it's our responsibility to unlock. So for that, we need to see unlock. So to release a reentrant, we call unlock. See here in the finally we use unlock. So we should always use in the finally block for unlocking. And this pattern is extremely important. Okay, acquire the lock before the try block. See, before the try block we should acquire, and we should execute the critical section in the try block, and in the finally block we should call the unlock. We should unlock in the finally block. You might be thinking, okay, why finally block? So because the finally block executes even if an exception occurs inside the critical section. You think like if any exception is occurring inside this try block or critical section, even then this finally block will get executed, and that's how we will unlock the critical section. So this helps ensure that lock is released. So this is the safe pattern you should remember whenever you manually lock and unlock. Okay. Now, so there is a mistake we should avoid. Okay, this is a dangerous mistake I mentioned at the beginning, right? So if you see this code, it will look correct. Okay, we are acquiring the lock. Okay, we are acquiring the lock, and we are performing some action, and we are unlocking. Okay, so we acquire the lock, we updated the shared data, and then we unlock. But what happens if updated shared data throws an exception? Exception will jump out before reaching unlock. Correct? So the lock may remain locked by the current thread. So the other threads will be keep on waiting since lock is not released. That is why manual locking must be handled carefully. Okay, so here what is happening, and what I'm saying here, let's say we have in critical section one lock is there acquired by one T1 thread, and we are updating some shared data. And during updating shared data, any exception occur, then it will not go to this line unlock. It will go to some exception and it will throw exception. And other threads waiting for acquiring these logs will keep on waiting. That's why we should handle this lock and unlock mechanism very carefully. Okay, so what is the solution? So solution is simple. Okay, simple but very important. Always place unlock in the finally block after successfully acquiring the lock. So once you acquire the lock, use try catch block. Okay, so inside try block you will writing this critical section lines of code, and inside catch whatever exception, and the finally block we should have the unlocking mechanism. That's how we can resolve this issue. So even if an exception is occurring, we will be releasing this log. We will release this log, and other threads, waiting threads, can utilize this critical section by acquiring lock. Okay. So this is like correct pattern. Okay. So first we should acquire the lock, then immediately enter a try block. Okay. Place your whatever protected critical section operations inside the try block and release the lock in the finally block. Okay, so lock, try, finally, and then unlock. So this ensures that even if something goes wrong during the protected operations or critical section operation, the unlock operation still gets a chance to execute. Okay. So this is like, okay, let's connect to the race condition example we learned earlier, right? For race condition. So we have a counter class in which we have counter instance variable, and we have the method increment, which is incrementing the count. So the count plus plus operation is not one individual operation. Multiple threads can interfere with each other. Okay, so here in example, let's say we have multiple threads which is incrementing the count instance variable. Okay, so multiple threads are interfering with each other can cause lost updates. So previously we have solved using synchronized. Okay, if you have seen that video, synchronization, we have seen with the example we were not getting 2 lakhs as an output. Okay, because each time one thread is incrementing count, during this process only another thread is trying to increase the count variable. So due to that, every time we were getting some different result. So when we use the synchronization with the synchronized keyword, we get the output as 2 lakh. Okay. Now let's solve the same problem using ReentrantLock. ReentrantLock. Okay. So using ReentrantLock, here we create a private final using. Okay. So we have created one lock. Okay. And inside increment we are locking. Then we are doing the critical section operation in the try block, and in the finally block we are unlocking, releasing here, releasing the lock. Even if we are getting exception, the lock will be released. So it will ensure like one thread at a time will utilize the count variable. Okay. So if another thread tries to call increment while the lock is held, it has to wait for that lock to become available. If one thread is incrementing the count, then other threads has to wait until the lock is released. And once the lock is released, another thread can acquire the lock and increase the value of count. So this protects our critical section from concurrent execution by threads using the same lock. Okay. So now just visualize the lock, how it is working. Okay. So the flow is like straightforward. Okay. So thread 1 is calling lock. So lock is acquired. It enters the critical section and it increases the value of count. Okay. And let's say in between thread 2 is trying to acquire the same lock, but it is already owned by thread 1, right? So thread 2 needs to wait. And when thread 1 completes its operation and call unlock, that is call is released, then lock become available and thread 2 can acquire the lock. Okay. That's what. If okay, meanwhile means if thread 1 is acquiring and thread 2 is trying to acquire, then it needs to wait. Okay. And it can acquire after release. So this gives us a mutual exclusion similar to synchronized. So using ReentrantLock, we are achieving the same thing. Okay. If both can provide mutual exclusion, why would we choose lock over synchronized? That is the question. With the help of synchronization also we are getting the same thing, and with the help of lock also we are getting the same thing. Then why would we choose lock over synchronized? So let's see. Okay. Synchronized is built directly into the Java language. Okay. It is simple to use. We define a synchronized method to make it synchronized. Method, or you can say block. Okay. And Java will handle monitor acquisition and release those things automatically. And when execution exits the synchronized this curly brace block or code, the lock will be released automatically. Okay. These are handled internally by the Java. So including when an exception causes the block to exit, this makes synchronized less error prone for many straightforward locking requirements. Okay. So it is simple in syntax, automatic monitor release built into the Java language. There is less manual lock. We have the less control on locking and unlocking in the synchronized. Okay. And in the lock API requires more explicit management. Okay. We will lock and we will do the unlocking. So locking and unlocking has to be taken care by ourselves, right? So we have like more control, explicit control over locking. Okay. So this makes the code slightly more, okay, more control. Okay, but in return it provides like more responsibility, more capabilities. Okay. So we can attempt lock acquisition using tryLock. Okay, there is one advantage. We can use tryLock. We can use lockInterruptibly when we want a thread waiting for a lock to respond to interruption. In such cases, we will use that. And ReentrantLock can optionally be created with a fairness policy. And lock can create conditional objects, okay, for more flexible waiting and signaling patterns. And we have seen the explicit lock control. So synchronized gives simplicity and lock gives more explicit control and additional capabilities. Okay. Now tryLock. So one of the biggest advantage of the lock API is tryLock. With the normal lock method, a thread waits until it can acquire a lock, okay, unless interrupted. So with tryLock, here we are calling tryLock method. So we can attempt to acquire the lock immediately, okay. So let's say we have lock and current thread is trying to acquire this lock. So we can acquire lock immediately with the help of tryLock method. If it is available, lock is available, we acquire it and execute the whatever critical section code, okay. And let's say if it is not available, it is acquired by some other thread, this lock is acquired by some other thread, so tryLock will return false and our program can choose another actions, okay. So we can also use a timed version of tryLock. So this additional control can be useful in designs where we want a thread to wait indefinitely for a lock, okay. It can also help in certain strategies for avoiding like deadlock, okay. So this is an advantage of tryLock, using tryLock. Now there is one quick question, let's test your understanding. So thread 1 currently owns the lock, okay, owns the lock and will hold for 10 seconds. And thread 2 calls tryLock. So will thread 2 automatically wait for 10 seconds? That is the question. So the answer is no. The immediate form of tryLock attempt is to acquire the lock without waiting. Because the lock is currently available, it can return false immediately, right? So thread 2 can do something else instead of simply waiting. So this is a type of control that synchronized does not directly provide. So tryLock, see, this lock is already captured by thread 1 and thread 2 is trying to acquire the lock, but since it is acquired by thread 1 already, thread 2 will wait. So instead of waiting thread 2 will do some additional task until waiting, okay. So that is an advantage. This is a type of control, okay, which we will not get in synchronized, okay. Now we will see fair lock. So reentrant lock also supports an optional fairness policy. So if we create an reentrant lock, okay, so here we are creating new reentrant lock with value true. So it uses a fair ordering policy under contention, okay, that generally favors threads that have been waiting the longest, okay. So let's say some thread are waiting for a longer period of time, so fairness has to be taken care here. So fair locks may reduce overall throughput compared with the default non-fair mode. And fairness does not mean we can predict the exact operating system scheduler order. So fairness should be enabled because the application actually requires the policy, okay, not simply because fair sounds better, okay. So it tries to favor longest waiting thread, okay. So fairness may reduce throughput. So these are the pointers we should know for fair lock. So now we will see the difference between the synchronized and the lock or reentrant lock we have seen. Lock is the interface, reentrant lock is the implementation class of the lock interface. So let's compare them directly. So synchronized is built into language, okay. Here it is a concurrency API. So automatic monitor release, okay, this is done by Java automatically. We are not locking and doing unlocking. But here in case of lock, we are doing manual lock and unlock. So in finally block, we used to release the lock. It is simpler, but here we have more control with more capabilities, more flexibilities here, okay. Here no tryLock is not supported. We cannot directly call tryLock. Here tryLock is supported. And here intrinsic monitor wait or notify, here based on the condition, okay. And good default for simple locking. So if you want requirement is like simple locking, go for synchronized. And if you want to like have better control, better explicit control, you want to control how the locking and unlocking, when to lock, when to unlock, in such cases for advanced control, go for lock or reentrant lock, okay. So for straightforward mutual exclusion, synchronized may be simpler and clearer solution, okay. And use explicit lock when you actually need the additional control it provides, okay. Now, which one we should use? So if you simply need straightforward mutual exclusion, synchronized is the right choice. Okay. And if you need advanced lock control, then lock and reentrant. Okay. If your application requires more advanced lock management capabilities, such as tryLock, interruptible acquisition, optional fairness, multiple conditional objects, okay, objects, this kind of thing you require, then go for Reentrant lock. Do not use explicit lock simply because they'll look more advanced. Choose the simplest mechanism that correctly solves your concurrency requirement. So based on requirement, we should analyze and we should choose the appropriate option. Okay. So this is like a simple model. We should understand look is what normal interface, and the implementation class of this lock interface is ReentrantLock. Okay. Now call lock to acquire the lock. And once we acquire the lock, critical section will get executed. And in finally block, we are releasing the lock. And one golden rule we have seen, always release the lock inside finally block. That is the most important point. Okay. So that pattern helps prevent one of the most dangerous mistake with explicit locking. So we should always use unlocking in the finally block. That's all for this video. I hope you now have a clear understanding of lock and reentrant lock. Thanks for watching, and I will see you in the next video.